So if you see the first one, we have a to the m times a to the n. So in this first column here, just see if you can remember what that property is, what happened to the property, what involved with the property. So see if you can just fill out those properties. So for the first one, what do you do when you have a to the m times a to the n? What are you supposed to do with the exponents? Fine? Add them, yeah. So that gives us a to the m plus n. So you're supposed to add the exponents. When the bases are the same and you're multiplying, you add the exponents together. So if you look right across from it, this is what the problems are going to look like. So we have 4 to the 1/2 times 4 to the 3/2. So you're supposed to add them together, so we have 1/2 plus 3/2. Hunter, what is 1/2 plus 3/2? Yeah, so this gives us 4 to the 4/2, which is really 4 squared. So adding fractions, you have to have a common denominator, which we do. So you just add the numerators together. So that gives us 4/2, which is 2. And 4 squared is 16. So that's completely simplified when you get it down to a number. That cannot be broken down any further. So we don't want to leave it as 4 squared. We want to break it down as far as it can go. So the second one, we have a to the m, and then outside is the exponent of an n. So this is a power to a power property. What are you supposed to do with those exponents? Julia?
You multiply them together.
Yeah, you multiply them together. So m times n. So if you look, we have 2 to the 5/2 times 2. So we're multiplying the 2 with the 5/2. Julia, what is 5/2 times 2? Yeah, that's just 5. So if you need to do a little side work, just to kind of show you how you're getting that fraction, we have 5/2 times 2. Well, make it 2 over 1. So 5 times 2 is 10, divided by 2 is just 5. So 5/2 times 2 is really just the 5th power. Julia, what is 2 to the 5th power?
32.
32. So we multiply the exponents, got 2 to the 5th, and that makes 32. Number 3, we have AB inside to the exponent of m. Mackenzie Myers, do you remember what happens with that one?
You distribute it.
Yeah. So distribute to both A and B. So if we're using that property and distributing it to both, we have 16 to the 1/2 times 4 to the 1/2. And those are exponents. So what happens if you have 16 to the 1/2 as an exponent? Odette?
Just square root it.
Yeah, that's really just the square root of 16 and the square root of 4. So a 1/2 exponent is the square root. Remember, that denominator is what makes the radical part, that square root part. So Odette, 16, or the square root of 16 is, and the square root of 4 is, so that gives us 8. So property number 4 we actually just talked about. We said if you have a negative exponent, that puts it under 1, and it makes the exponent positive. So if we have 25 to the negative 1/2, that's really 1 over 25 to the positive 1/2. So negative exponent makes it a fraction under the value of 1. And then if it's a square root, because it was a power of 1/2, we now have 1 over the square root of 25, or 1/5. So negative exponent takes it to the denominator, the fraction makes it the square root, and then you're evaluating it. So there are two more here, both dealing with division. So we have a to the m divided by a to the n. Matt, what happens when you're dividing? What do you do with the exponents? When you are multiplying, what do we do with the exponents? Okay, so what was that option you said? Subtract them. So a to the m minus n. So we have 3 to the 5 halves divided by 3 to the 1 half. So we're really taking 5 halves minus 1 half. What is 5 halves minus 1 half? Yeah, because that gives us 4 halves, which is really 2, and 3 squared is 9. So exponents, when you're dividing, you're really subtracting those powers. Again, because the fraction has the same denominator, we can subtract them. And then the last one, number 6, is very similar to number 3, but we have it in fraction form. So that little power of m distributes to both of them. So a to the m divided by b to the m. So that means we have 27 to the 1/3 divided by 8 to the 1/3. So the exponent distributes to both numbers as an exponent. So Maggie, what happens when you have an exponent of 1/3? What does that really mean? Very good. So this is really the cube root of 27 and the cube root of 8. So anytime you have a fraction exponent, that now makes a radical. Maggie, what is the cube root of 27? And the cube root of 8 is? Nice job. Question. So we're going to look at some examples that are a little more involved than just having a common denominator. And there are 4 examples at the bottom, and then a bunch of examples on the next page. We'll just see through any examples we can kind of work through today. We'll work through some more tomorrow. So at the bottom, it says use the properties of the rational exponents to simplify the expression. So the first one, we have 9 to the 1/2 times 9 to the 3/4. So the key thing is that the bases are the same. So we have to have the same base in order for us to combine them together. How would you combine those exponents together if you're multiplying the bases? What are you supposed to do with them? So what would the property say, at least? Fun? Yeah, you add them together. So our goal is to add 1/2 and 3/4 together. So you take the exponents, you add them together. How do you add 1/4 or 1/2 and 3/4 together? Abby? Yeah, we need to get a common denominator. So we need to take the 1/2, multiply each one of those by 2. So really, we're taking 2/4 and 3/4 and adding those together. So common denominator, there is a 2 and a 4, so we have to multiply the 2 by 2 to make it 4, but also the numerator. So Abby, when you add those together, what does that give you?
5/4.
9, right, so 9 to the 5/4. All right, so here's where it gets a little different, because you can't leave it like that. So we need to try and simplify this. Use the properties to simplify the expression. Sure, we added the exponents together, but the expression is not necessarily simplified right now. So we have an exponent of 9/4, and typically I would tell you to just immediately flip and write this as a radical. But before we do that, I want you to simplify this fraction, and I almost never tell you to write it as a mixed number, except in this I'm going to tell you if it's a big fraction, we want to try and write it as a mixed number to help us break this down. So if you have 5/4, what is 5/4 as a mixed number? And this is probably the only time that I'll ever say to write something as a mixed number. So what is 5/4 as a mixed number? Odette?
1 and 1/4.
Right, so it's 9 to the 1 and 1/4. So 5/4 is really 1 and 1/4. The reason I want you to do that is because our goal is to try and simplify this and break it down. So I'm going to use the opposite of what the property that we had up there. If I have 9 to the first times 9 to the 1/4, that is the same thing as having 9 to the 1 and 1/4. So we're breaking it apart because our goal is to try and simplify this. So now I have this whole number of 1, 9 to the first, and that just becomes 9. This part here is the part then that you want to change into radical form, because now I've pulled out that whole number part and we've separated it from the problem. So if we have 9 to the 1/4, that would be written as a radical as the 4th root of 9. So we took the exponent of 5/4, made it into a mixed number. The whole number actually creates a whole number of 9. If it was 9 squared, then we would make it 81. And then whatever's left as the fraction, that's the part that we want to write as a radical. Can you take the 4th root of 9? Can 9 be broken down at all? No. So then this is completely simplified. But if we had a number bigger than 9 that we could break down because it had a 4th root in it, then we would want to do that. Questions? Alright, so let's look at the second one. We have 7 to the 2/3 times 5 to the 1/6, and then it's cubed. So Melanie, what are you supposed to do when there's an exponent outside?
You distribute it.
Exactly, so let's distribute it. So you're taking 2/3 times 3 and 1/6 times 3. And if it helps you to write it out so that you physically see that, you don't have a calculator to use. So sometimes the more you write down to physically see, the easier it is to do some mental math. So Melanie, 2/3 times 3 is?
2.
You're right.
6.
No, you're good. 2/3 times 3 is 2, so that's 7 squared. And then 1/6 times 3 is 5 to the 1/2. So Melanie, 7 squared becomes,
49.
and then what would you do with 5 to the 1/2?
You do the square root.
Perfect. Square root of 5. Again, if you want to write a little 2 here, you can. You don't have to. Melanie, can you break down the square root of 5?
No.
No. So 49, and then the square root of 5. Questions? Okay, so trying to do the same thing with C and D here, just trying to apply those properties. So letter C, we have 3 to the 5/6 divided by 3 to the 1/3. Garrett, what do you do when you have exponents and you're dividing? Yeah, so we want to subtract 5/6 minus 1/3. So Garrett, that really becomes 5/6 minus 2/6, yeah. So the top is a 2, the bottom is a 6. Which gives us, and 3/6 is really 1/2. So we have the square root of 3. So change, so you have a common denominator. 1/3 is really 2/6. You have to multiply each by 2. Subtract 5/6 minus 2/6 gives us 3/6, and then reduce and make it into a radical. Questions? So the last one on this page, we have 16 to the 2/3 divided by 4 to the 2/3, and then that's raised to the 4th power. So what do you think you'd do first? There's 2 different things that you could do. Abby?
Could you simplify the fraction first?
Yeah, so inside you have a 16 to the power of 2/3 and a 4 to the same power of 2/3. So because they're to the same exact power, you can simplify that. So Abby, that would become,
4.
yeah, it just becomes 4. So you're just reducing the fraction part. It's still 2/3. The reason you can do that is because the exponent is the same. So if they have the same exponent, you're allowed to simplify that fraction. It's still to the exponent of 2/3, it still has a 4 outside. We're just simplifying the 16 and the 4 because they have the same exact exponent. So you can reduce them. So Abby, what would you do second then?
You distribute the 4.
Yeah, we're going to distribute the 4. So we would write that as 4 to the 8/3 because you're taking 2/3 times 4 over 1. So you're multiplying those two fractions together. And now we're going to try and break this down. So our goal is to simplify it. We want to break the exponent down. So this is where I want you to take this exponent, and before you write it as a radical, I want this exponent to be simplified as a mixed number first. So we have 4 to the 8/3. What is 8/3 as a mixed number? Will, you know what 8/3 is as a mixed number? 2 and 2/3. Sorry, that 2 is kind of big. Okay, so we're going to split this apart because our goal is to simplify. So we're going to keep the 4 squared and then the 4 and 2/3. So this is one of those problems where it's a multi-step problem. There's a couple of things that we have to do to get this to simplify. The 4 squared part becomes 16. So that's the whole number that we pulled apart from that fraction. So now that's 16. The other part we're going to write as a radical. So if we have 4 to the 2/3, what does that become as a radical? How do you write it as a root? Melanie, do you know?
Would it be this, the square root of 4 and then times 3?
Flip it around. So,
It's cube root of 4.
yep, the cube root of 4. So the denominator makes the root, and then that's squared. Alright, so our goal is to simplify this completely. Can you take the cube root of 4? No. But there's a squared out here, and this squared can also be applied to the 4. And you can do that part first to help you simplify it. So if you can't do the root part, then you can try and do the exponent part. So we're going to work through the exponent part first because we can take 4 squared and make it 16. So now we have a 16 outside and a 16 underneath. Can you break down 16 because there's a perfect cube in 16? And Emma, you're shaking your head, yes. How can you break down the cube root of 16? Yeah, you can take out an 8. So this becomes the cube root of 8 and the cube root of 2. So we broke it down as square roots before, now we're breaking it down as cube roots. So the cube root is 16. 16 is really 8 times 2. The reason we're picking 8 is because 8 is a perfect cube. It's in that column of your perfect cubes. So Emma, the cube root of 8 becomes, and we still have the cube root of 2, and you still have this 16. So the 16 that we pulled out from the very start, that was the first thing that we pulled out, now gets multiplied by the 2, which we found because we took the cube root of 8. And this becomes 32 cube roots of 2. So one little problem ended up having a couple of steps involved in it. So we broke down the fraction in the middle, we distributed, and then it's just continuing to break down. So we'll stop there for today. Again, the homework, it will be a little challenging. So a lot of the problems are going to be similar to that last one, where you just need to keep on breaking down that number. And if you start with your fractional exponent and break that down first as a mixed number, that'll really help kind of save some of the problems from being really large values. Trying not to rely on that calculator. So page 424, numbers 3 to 31. Have an awesome day.